Today, I'm going to show you how you can deploy an EKS cluster to AWS using Terraform. So Terraform is the most popular infrastructure as code tool. And if you don't know what infrastructure as code is, it is one of the key principles within DevOps. And also, this video is part of the DevOps Capstone project series. So if you don't know about that, go check out my channel. Hi, I'm Rishabh. This is Rishabh in Cloud, and let's deploy our EKS cluster today. So before I begin, this is my second take at this video. And the reason is, so I have this main.tf. And if you don't know about Terraform, there are beginner crash courses available on my channel. So I highly recommend you check that out as a prerequisite. But coming to our main.tf, this has all of the resources that needs to be deployed in order to have an EKS cluster in AWS. But what happened is, as I was deploying my EKS cluster, I realized that there is an EKS provider available in the Terraform registry. As you can see, I was just using the AWS provider, so which means I had to handle a lot of things like VPC, all the subnets, all the IAM policies and roles for our managed EKS cluster. But with the EKS provider, it is very easy to do that. And that made me remember that Lou from Open Up the Cloud did something similar, which deploys a minimal EKS cluster using Terraform. So here's the repo that is available. If you go to Open Up the Cloud, the repo is called k8s starter EKS Terraform. And you can see the idea is to give you a minimal EKS cluster. So I'll refactor a lot of this main.tf to use not only the EKS module instead of the AWS module. And also, I'm going to follow a lot of the example from Lou's repository because this will give us a minimal EKS cluster. Again, I'm running this project on my AWS account, so I don't want to incur a lot of charges when it comes to my AWS bill. Hence, we'll be going with minimal cluster here. But the main idea is to understand the principles behind this DevOps Capstone project. So since we'll be using this Terraform AWS EKS module, you can see within the GitHub repository, which you can find the link in the EKS provider page. I'll make sure all of these are available in the description. But if you look at examples, what I'm definitely looking for is the EKS managed node. So if you don't know what EKS is, it's Elastic Kubernetes Service from AWS. And yes, it is a managed service. So a lot of the operations and services and settings are managed by AWS itself. You don't have to manage that on your own, but there's also the self-managed node group example. But I want to use the EKS managed node group, and you can look at the example under main.tf. Since that is out of the way, let's go back, and I'm going to start from scratch. So let me get rid of the main.tf that I already have. So to get started, as you can see on the right-hand side, I have my infrastructure folder, and it is empty now. But what we'll do is create our main.tf. This is where most of the Terraform configuration will live. And as I said in the beginning, this is part of the DevOps Capstone project. So until this part, all of the things that we have covered are in other directories. Now, for main.tf, first of all, you have to define a provider, which in our case will be AWS. But also, before I go any further, make sure you have the AWS CLI installed. As you can see, in my case, I have the 2.4.6 installed on my machine and also the Terraform installed. For Terraform, I have version 1.8.1. So make sure both of these are installed, and specifically for AWS, the CLI is configured, which means you have authenticated to your AWS account, because otherwise you cannot deploy your code that will have as Terraform configuration. Awesome. So let me go to the Terraform registry and we'll go for AWS provider. This is the official provider. So as you can see here, we can specify the required provider. So we'll go into our main.tf, paste that in there, and also have the region specified. So for our AWS provider, we are going to use US East 1. This is the region that works for me, but you can pick, US West, or if you're in other parts of the world, you can pick the region appropriately. So once that's out of the way, now we can work on creating our resources. So the first resource we want to create is the VPC itself. And along with that VPC, we'll also need some subnets. Let's name this VPC as main. And now we also need a CIDR block. I'll use the 10.0.0.0/16. Again, for the purposes of this tutorial, I'm gonna stick to the EKS cluster mainly. You can learn about VPC and networking and how to calculate CIDRs of how many IPs you need. There are a bunch of resources available online. And we'll also enable the DNS host names and set it to true. So this gives us our VPC. Now, you can either create 2 subnets or 3 subnets depending upon your requirements of the project. So I'm going to create the first subnet. And the way you do is you use AWS_subnet, name the subnet whatever you want. So in this case, it will be subnet 1. And then for the VPC ID, we reference to our main VPC that we created in the previous resource block. So AWS_VPC.main.id. And again, as I said, the CIDR calculations, you can do it, but we'll be using /20 for our first subnet. You can specify the availability zone. So this subnet 1 will reside in the availability zone 1B. And we are also going to have the map public IP on launch set to true. Similar to this block, I'll go ahead and create 3 more subnets. Okay, so as you can see, we have 3 subnets now, subnet 1, 2, and 3. They are all in different availability zones. So one is in 1B, 1C, and then the third one is in 1D. And all of them have the public IP on launch set to true. As we have set up our VPC along with the subnets, we'll also need an internet gateway to give this VPC access to the internet. You can also use your default VPC. Again, it all comes down to how you want to provision your resources. So here I'll define the internet gateway. So you do that by typing a new resource block and AWS_internet_gateway, and we'll call this internet GW. And you have to specify the VPC ID, which in our case is the main VPC that we created here. Okay, so now that we have our internet gateway, we also need route tables to route the traffic through this internet gateway. And in order to create a route table, you start with another resource block and type in AWS_route_table, and we'll name this as route_table. The first thing we have to specify is the VPC ID. And as you can see, Copilot is taking over with some suggestions. That is correct. And you also have to specify the route. So for the CIDR block, for the first route we need is the internet access. So we'll go with 0.0.0/0, and this should go through the gateway. So we need to specify our internet gateway ID, and this will be the AWS internet gateway.internet_gw.id. That looks right. And we also need a local route. So this local route basically allows the network communication within the VPC itself. So this will be our VPC CIDR, which is 10.0.0/16. And for this, the gateway ID is set to local. So I forgot a curly bracket here, which is why we were getting an error. So this resource block is for our route table. So our networking bit is kind of covered. So we created a VPC, we created 3 subnets in 3 different availability zones. And we also created an internet gateway to provide our VPC access with the internet. And we also created route tables to enable that access. Now, the fun part begins, which is the use of the EKS module. So this is the module that we'll be using now. Specifically, I'm going to stick to Lou's example. So as you can see, here is using the EKS module, and we have some cluster name. I'll go over the code once I have in my main.tf. But shout out to Lou. He also has this video on how to get hands-on with Kubernetes using AWS and Terraform, which kind of helps you set up an EKS cluster and deploy. I think he deploys a simple Docker app for Nginx, but a lot of amazing knowledge and information is shared in his video, so go check it out. So coming back to my Terraform file, I'm going to paste it as is, and I'm going to quickly explain what's happening. And this bit of our Terraform file is also going to be the final part of this configuration. So here we are using the EKS module from the Terraform registry. We're also using version 19. And the next thing we specify is the cluster name and the cluster version. So I'm going to name this to DevOps Capstone project. We're also enabling the cluster endpoint public access, so that is why it's set to true. Now, for the VPC, we are going to associate it to the main VPC we created, which is up here on top. And for the subnet IDs, we list all the 3 subnets that we created. For the control plane itself, we are also going to mention all the 3 subnets that we are creating before in this main.tf. And you might be wondering, what is a control plane? So as I was mentioning, EKS is a managed service, which means a lot of the settings and configuration and management is done by AWS itself. The EKS control plane is how it's done. So EKS control plane will be installed in all of these 3 subnets, which means the control plane nodes that run softwares like KDE itself or etcd, and also the Kubernetes API server. Those nodes will also exist in all of these 3 subnets. So that is what this one line is doing. And you can read more about the control plane and how it works. But since in our case, we are going with the EKS managed node groups, we will be relying on AWS for a lot of things. The last thing is our managed node group configuration. So here we can define how many nodes do we need. So the minimum size is 1, which means there will be at least 1 node. We can set the maximum to 2 and set the desired size to 1, which means at least 1 node will run. So now you can change this again based on your own needs. You can set minimum to 2 and maximum to 4 if that's the use case for you. But I'm going to leave it to bare minimum. For the instance types, I'm going with the T3 medium. This is also what the EC2 instance size will be for our nodes. So for more on that, you can look up EC2 instance size. So you can see this is the T3 instance that I'll be using. The cost and specs for this is available here. So T3 medium will have 2 vCPUs and 4 gigs of memory. I think that is pretty good. So I might change instead of max size to 2, just to 1. So we'll only have 1 node as the max and also the minimum. And that is also what our desired size will be for this particular node group. I'm going to hit Control S, which will save our configuration here. If you check out my other Terraform videos, I've talked about best practices and stuff. So what we can do is basically get the provider out of the main.tf, and let's create provider.tf. So I'm going to cut this out and have this in our provider.tf configuration. And here, let's get rid of the white space. And now we can initialize this project with Terraform in it. So let me clear my terminal here. And what I can do is go to infrastructure folder and do Terraform init. This will initialize our Terraform project. And as you can see, it is downloading the required provider and modules. So in our case, as we have the AWS provider and also we are using the EKS module, it'll download all of the necessary things that are needed for our main.tf. Now what we can do is run Terraform plan and see what the plan looks like. Okay, so there are 29 resources that need to be added. But as you can see, we do have some errors. So the first one is name must begin with an alias. Okay, so I think it is because of this equal to sign. So I meant to have an hyphen in there. So I'm going to hit save, do Terraform plan again and see if that resolves the issue. And as you can see, we now have 36 resources that will be added, 0 to change, 0 to destroy, and no errors. So I'm going to do Terraform apply, and it'll ask for yes or no. Yes means that it will be accepted and all of the 36 resources will be deployed. So I don't think this will be done quickly. Come back once all of the resources that we have specified here are created.
A few moments later.
Okay, so nearly after waiting for 23 minutes and 11 seconds, our cluster creation kind of failed, specifically on the node creation failure. But let's look at our console within AWS. So if I go to AWS and go under EKS, we should see our cluster DevOps Capstone project. And you can see that it is active. But if I look into resources, so these are some pods, and I'm specifically going to look for nodes. And as you can see, there are no nodes. Let's look at the compute, and we can see there is one node group, and the desired size is 1, which was set by us, but the creation failed, as you can see in the status. So let's click on this and click on the health issue. Instance failed to join the Kubernetes cluster is the issue type for node creation failure. I'm not sure why it could not join the cluster, but let's look at our EC2 dashboard and see if the instance is in healthy state. Okay, so this is the green instance and it is running. T3 medium was our choice of size or instance type. As you can see, 3 of 3 checks passed. So something when it was trying to join the Kubernetes cluster failed. So let me retry the main.tf. So what I'm going to do is Terraform destroy, which will destroy all the resources. It gives me a good way to demonstrate destroy. And the way to do is you type in Terraform destroy. It asks if you want to destroy all of those resources. As you can see, it says 36 to destroy. And you enter yes, and it will clean it up. So what I'm going to do is destroy and then deploy again, and we'll see if it works. So the apply is complete, and as you can see, we ran into the same issue where the instance failed to join the Kubernetes cluster. Let's try to investigate this. So I think it can be a networking issue. Let's see what our VPCs are. So I have the default VPC, and this is the VPC that Terraform created for me. Within this VPC, we can see that all of these subnets, so these are the 3 subnets that are connected through the route table, which is not connected to the internet gateway, which, if I understand this correctly, you need the internet gateway so that, it's able to join the cluster. So we created a route table, which is a different route table. As you can see, there are 2. So what we want is all these 3 subnets to go through the second route table, which is connected to the internet gateway. I can do this manually too, so I can go into each subnet. So let's go into one of the subnets here, and you can see the route table. It doesn't have the route to internet gateway. So if I click on edit route table, I can select the other route table, which does have the internet gateway as target, and hit save. But that would defy the purpose of using Terraform as infrastructure as code. And in order to fix it within our Terraform configuration, right after the route tables are created, we want to associate those route tables to our subnet. So as we saw it in the AWS console, the route table was created, it's just not associated to our subnet. So in order to do that, we'll create a new resource block for that association. So as you can see, we have the AWS_route_table_association, and this is for our subnet 1. And as you can see, I'm picking the subnet 1 ID. So here, AWS_subnet.subnet_1.id will give us that. And similarly, for the route table, we have the main route table, which is right here. So I had that wrong here. Instead of main, it is called route table. I confused it with our VPC. So the route table is called route_table.id. So this will give us the subnet 1 to be associated to our route table. Now, we have to do this again for subnet 2 and 3. So I'll change this to 2, and then 3, and 3. There we go. I'm going to save this, and everything looks good. Now, I'll have to run Terraform destroy and Terraform apply again. So I'm going to quickly do that. So destroy was completed. We have 37 resources destroyed. Now I can do Terraform apply. Enter yes. So the apply is complete, and you can see 40 resources were added. We didn't get the error of the node group not being able to join the Kubernetes cluster, which is what we wanted. So the issue was with the route table association. And if you want, you can also go confirm it within the VPC tab. So what we were trying to fix is we needed our route table to be associated with these subnets so that they're able to talk to the internet gateway. And you can see right here under our VPC. Awesome. Now, you can run the AWS CLI command, specifically the update kubectl to get the configuration needed to connect to your EKS cluster. And the command is AWS EKS update -kubectl. You select the region. In my case, this is US East 1, and the name of our EKS cluster, which we named it DevOps Capstone project. Here we go. Hit enter, and you can see it added the new context to the local kubectl. Now, you can do kubectl get pods. Again, you'll need kubectl installed locally on your machine. So that is another tool that you'll need to install along with the AWS CLI and Terraform. And what I'm getting is an API version error. So I think I need to update my kubectl. Currently, we can check what do I have installed by typing in kubectl version. Okay, so I was able to resolve the issue. What I did is I upgraded kubectl. I also had to upgrade my AWS CLI. And after that, as you can see, I ran into the permission issue that my user, Rishabh Kumar 7, which is my CLI user, which was used by Terraform to deploy this. For some reason, it didn't have access to the EKS cluster. So what I had to do is under clusters, as you can see, this is our DevOps Capstone project cluster. If you click on access, you can add an access entry for your IAM role. Again, this was for me. I think I'm using a different user for my CLI, I guess. But if you run into the permission issue, you'll need to add your user here to the access tab in the cluster information. So now if I go to my VS Code in my terminal, I can do kubectl cluster info. You can see that we do get the EKS cluster information. Also, if I do get pods, we should get 0 since we have nothing running. But if I do get nodes, you can see that for nodes, I still have the permission issues. So I'll have to fix that in IAM, but you should be able to at least get the cluster info. Now, moving on, we have to push this code to our GitHub repository. As you can see, I have 16 changes. Well, that is not the case. We do need to add gitignore to our Terraform or infrastructure folder. So I'm going to quickly search for gitignore Terraform. And as you can see, here's the file. So I'm just going to copy this, come back to our VS Code and create a gitignore in our infrastructure. There we go. Paste that in there. And you can see instead of the 17 changes, we now only have 4. So I do want my main.tf, the log file, the provider.tf, and the gitignore. And for the commit message, I'm just going to say added ISC with Terraform. And there we go. I'll make sure that the GitHub repository for this project is in the link below. But I know this was a longer video, but I hope now you can deploy an EKS cluster with minimal configuration using Terraform. Also, again, shout out to Lou. I was able to bring down my Terraform file to 81 lines, but I can bring my previous file that we had where I was using the AWS provider, just the AWS provider, not the EKS module. So as you can see, this was 211 lines because we had to take care of all the IAM policies. So we had to attach, as you can see, the EKS CNI, the EC2 container registry, EKS worker node policy. Luckily, the EKS module came in handy and we were able to reduce this down to 81 lines. But yeah, if you're taking part in the DevOps project, I wish you luck. And I hope this video was helpful. I'll make sure to have the playlist link as well. But make sure you're subscribed and I'll see you in the next video. Peace.